Good day, good morning, good afternoon, good evening, whatever it is for you, whatever time zone you're in. My name is Andrea Copping with Pacific Northwest National Laboratory and OES-Environmental. And today we're going to present to you the work we have been doing really over the past year, from science to consenting, particularly the highlights this year. And with me are my colleagues, Michaela Freeman, Lynette Henry, and Lisel Garabelli, and Deborah Rose, who will be helping to present parts of this webinar. Next slide, please. Today, I'm going to give you a quick overview of OES-Environmental and TETHIS, though many of you may know these. I'll be handing it over to Michaela, who will talk about a series of the steps we go through with risk retirement and guidance documents. Lynette and Lisel will then take over to talk a little bit about what some of our focus areas are through the rest of this year and into next year. And Debbie will end up talking about outreach and some of our next steps. Before we get started, just a couple of notes. This webinar is being recorded, which I think you saw at the beginning, and it will be archived in a few days on TETHIS if you want to look at it again and share the link. I also just want to note that OES-Environmental is really focused on marine renewable energy, by which we define wave, tidal, and the like, and not on offshore wind, although there is a great deal of crossover with the environmental effects of offshore wind. Next slide, please. So the point here today is really for us to continue our engagement with the marine renewable energy, or the MRE community, really making sure that all the information that's collected worldwide is readily accessible. And we're also extremely interested in feedback. We want to know what you think of the products we're producing, the processes we're going through. We particularly are interested in these what we call our new topics, or our systems approach and our outreach efforts. So please, during the webinar, later on, please reach out to us. We will be keeping the audience muted during this time, and if you wish to ask questions, please put them in the chat, and we will address those questions at the end. Okay, with that, let's go ahead. So OES-Environmental, this is a task that was established under the International Energy Agency's Committee Ocean Energy Systems, which is made up of over 25 countries. It's been running for about 15 years now, but this task was established in 2010, and the purpose is to examine environmental effects of marine renewable energy in order to advance the industry in a responsible manner. The U.S. leads this task. The U.S. Department of Energy is the lead, along with their federal partners, Bureau of Ocean Energy Management and the National Oceanic and Atmospheric Administration, NOAA, and it is implemented by Pacific Northwest National Laboratory, our lab. We are in a fourth phase of OES-Environmental, 3 or 4 year phases, so we've been going at this a while, and there are currently 16 countries involved in this process, and you see them represented there. The greatest thing that we do probably in each phase is punctuate it with a State of the Science report. And there you see the image of the 2020 State of the Science report, which is, of course, the most recent. And it is now 2022, so we'll be heading towards a 2024 report pretty soon. Next slide, please. All right, marine renewable energy, as I mentioned, we're talking about energy harvested from waves and tides, other ways in which the water move, large rivers, persistent ocean currents, and also gradients of temperature and salinity within the ocean. This industry, as many of you know, is still in fairly early stages of development, deployment, and commercialization. But we see that environmental concerns, even after a decade or more of working on this, they continue to slow the consenting or permitting process. And by the way, because of our international audience, we will use consenting and permitting interchangeably. They're really just terms that are used in the same way for regulatory processes in different countries. Now, we have been examining environmental effects through the stressor-receptor relationships, where stressors are those parts of the system that may cause stress, injury, or death to animals or habitats, and the receptors, of course, of those animals are habitats. And the 7 key receptor stressor interactions we've been looking at are collision risk, effects of underwater noise, effects of EMF from cables, changes in benthic and pelagic habitat, potential for large animals to encounter mooring lines, changes in oceanographic systems, and finally displacement. And we're not going to delve into these to any extent, except for those that we really feel we have not made as much progress as we'd like to on: collision risk and displacement. Otherwise, we've been going through a process we call risk retirement, which will allow for not complete investigations at each new site where 1 to 4 devices might be deployed. Next slide, please. So what will it take to move this industry forward? We are really at the stage where we have to get more devices in the water in order to collect the monitoring data, test hypotheses, and also validate the numerical models we've been building to try to understand these interactions. And this just gives you a little sense of where OES-Environmental is in trying to move this industry forward. We are publicly sharing all available information through TETHIS and PRIMRE, which I'll talk about in a moment. We are sharing best practices for avoiding and minimizing harm, which comes from our management measures tool, which Michaela will talk about. We are systematically using data collected at existing projects to apply to new projects through data transferability and risk retirement. We are making science available for regulatory purposes through the guidance documents. And we are now really trying to expand the research focus into some new emerging areas, which is really more of a systems approach. And throughout this, transparency is key, sharing these results publicly. Okay, next slide, please. So I mentioned PRIMRE. PRIMRE, the portal and repository for information on marine renewable energy. That's why we call it PRIMRE. This is the US system for collecting all data and information on environmental effects. And it provides centralized access through that center point. And this drawing here is really supposed to show you that there are 7 knowledge hubs that surround the central point. And the central point is an entry where one can use one set of search strings and reach information in any of these different knowledge hubs. I'm not going to go into those today. We've done a couple of webinars on them already, but it lets you get at such things as data sets, papers and documents, information about MRE projects worldwide, codes and software used in the industry, guidance on testing, etc. And one of those knowledge hubs is TETHIS. And if we go to the next slide, TETHIS is our publicly available knowledge management system that was developed and is maintained at PNNL. I think many of you are familiar with it. There's the URL right on top there, and Debbie is putting in the chat while we speak. She is adding some of these links if you want to grab them. All our OES environmental activities are documented on TETHIS. Right now, there's over 4,000 documents on marine renewables. Those are papers, reports, etc. There's also a series of tools. We archive our webinars there and other items. And if you haven't already, TETHIS Blast is our every other week email newsletter that gives you news and events, new additions to TETHIS, etc. I do also want to note that TETHIS supports marine renewable energy and also wind, both offshore and onshore. But that is not the focus of today, though hopefully any of you who are working primarily on offshore wind will see that there is a good deal of overlap and usefulness of the information you get here today. Okay, next slide. And here I'm going to turn it over to Michaela to begin to talk to you about some of our tools.
Thank you, Andrea. So as Andrea mentioned, TETHIS hosts many tools developed by OES-Environmental, and the one I'm going to highlight today is this management measures tool. It compiles management measures that have been used and tried for current and previous MRE projects. As Andrea mentioned, our way to share kind of best practices within the industry. So by management measures, or sometimes what's also referred to as mitigation measures, we mean actions taken to help address potential impacts of these MRE developments, and they can really be applied at different steps in that development process. Within the tool, management measures are related to compliance, design feature, mitigation, or monitoring. And the tool itself allows users to search for available information, filter by categories or by keywords, and download the information to an Excel spreadsheet. While the tool itself was created in 2017, we recently completed improvements to it and updates to include additional information from MRE projects that have been developed and come online since 2017. And we do plan to host a webinar in late 2022 on this management measures tool and other tools for environmental effects at MRE. So if you're interested, you can sign up for the Tethys Blast to get notified. Next slide, please. So for the rest of the webinar, we're going to dive into some of our focus areas for OES-Environmental. And the first one that I want to talk about is risk retirement. And this is another resource that you can find more information on the Tethys website. Risk retirement itself was developed after really hearing the need to provide mechanisms to transfer existing MRE data and information to new projects, and to also understand certainties and or uncertainties to guide research and assess risk. By risk retirement, and as Andrea mentioned a little bit before, I mean that for certain interactions, potential risks may not need to be fully investigated for every project for small numbers of devices, which we've defined as about 1 to 4 devices. And instead, what we can do is rely on what's already known from consented projects, from research and analogous marine industries, and use data transferability to inform. I do want to note 2 things. 1, that a retired risk can be re-examined in the future if new information arises. And 2, risk retirement does not replace or contradict any regulatory processes. Overall, the development of this concept has really been an iterative process, as shown by this figure here, where we've gathered feedback along the way from the MRE community through workshops, webinars, surveys, and reviews of draft documents. I won't go into too much more detail today, as we've presented on this in previous webinars, which you'll find on that risk retirement page on Tethys. And there's recordings of those webinars and associated resources that you can find on that page, including our evidence bases, which consist of key documents and reports to inform risk retirement, our monitoring data sets discoverability matrix, another tool on Tethys to help transfer data from past or current MRE projects to future projects, and the guidance documents, which I'll talk more about in the next 2 slides. So next slide, please. So one key piece of feedback we received in kind of this iterative process in developing risk retirement was the need to make information easily available and accessible for application and consenting processes. So because of this, the guidance documents were created to move from scientific evidence to application in a regulatory context and to provide guidance for this application internationally. They're really geared towards regulators who are consenting and licensing projects, advisors who are assessing information and informing regulators, and MRE developers as they prepare these fit-for-purpose applications. As shown in the screenshot on the right, which is our guidance document page on Tethys, the guidance documents themselves include a background document that details the purpose of the document. It defines regulatory categories that guide this work, and it also provides a framework for application of this information. It also includes country-specific documents, which provide high-level overviews of MRE environmental regulations and which are being developed for the OES-Environmental countries. So far, we have documents for the US, Wales, China, Japan, and we just added one for Spain as well. And we have other draft documents for Scotland and France, and we hope to include the other OES-Environmental countries as we continue to work on developing these documents. Last, we have the stressor-specific documents that present an overview of the stressor-receptor interaction. They link to available data and information and OES-Environmental tools where you can find resources, and they detail where we're at with risk retirement for each of these interactions. So far, we've completed EMF, electromagnetic fields, underwater noise, habitat change, and oceanographic systems. And the rest of this year and in 2023, we'll be drafting documents on entanglement and collision risk. And again, all of these documents and associated information can be found at the Tethys link at the top of this slide. Next slide, please. So as with risk retirement, development of these guidance documents has also been a really iterative process to assure that we receive feedback and review at each step. We want to make sure that anything that we're producing will be impactful and useful. And so we've done a lot of outreach and engagement here to work with the MRE community. And so the figure here just shows a little bit of those different groups that we've conducted outreach with and received feedback from. And it includes our OES-Environmental country representatives, US and UK regulators and advisors specifically, and then the larger MRE community. Our next step for outreach is to host workshops on the guidance document for the larger international regulatory community. And so we'll be inviting regulators and advisors to a separate set of workshops, really to provide a deep dive on the guidance documents, understand the ability to use and apply these documents in different consenting processes internationally, and gather feedback to continue to inform and develop these guidance documents. So we're just starting to plan this. So if you are a regulator or advisor on this webinar today and you're interested, or if you have colleagues who may be interested, please let us know. And so, yeah, that's been a lot of the work we've done on the guidance documents. And we're really looking forward to engaging more of that international regulatory audience. So now I am going to pass it to, I think, Lisel, who will tell us about OES-Environmental's current focus areas.
Thank you, Michaela. So I'm now going to give a quick overview of the new focus areas that we have been looking at recently. And these are a system approach looking at scaling up to array, at cumulative effects, and at ecosystems, as well as investigating environmental effects in tropical and subtropical region, looking at displacement, and continuing our exploration of collision risk. So next slide, please. As the industry progresses, it is time to take a holistic approach and look at potential system effects. And to do so, OES-Environmental has been exploring 3 new focus areas over the last year or so. So these are the scaling up of effects of marine energy from single devices to large arrays, cumulative effects of marine energy with other anthropogenic stressors and activities at sea, and the ecosystem effects of marine energy, including ecosystem services and what we call an ecosystem approach. So we have white paper on each topic coming soon, and I will now summarize each of the 3 focus areas in this order that I just presented. So next slide, please. So the first focus area, scaling up to arrays, is led by Dan Hasselman from Force in Canada. And so far, we have mainly examined each stressor receptor interaction on its own and for single or small number of devices. Here on this topic, we are looking at the scaling of the environmental effects to realistically large arrays of devices, something like 10 to 30 devices, depending on the technology. And the main questions that we want to address are how to apply to arrays what we have learned from single devices, and how we should examine the interaction that are not relevant around single devices, but will become relevant with arrays. Next slide, please. So this graph shows our level of understanding for single devices for each stressor receptor interaction and how applicable this knowledge is to arrays. For collision risk, we still don't understand very well what happens around single devices, even though very few collisions with turbines have been observed. So this risk is very site and species specific and tricky to scale up to arrays. So then we have changes in oceanographic systems and displacement. So these ones are not really relevant at the scale of single devices. So we need arrays in the water to investigate these effects. And so far we have used numerical models, but they need to be validated with real data. Then we have effects from electromagnetic fields, underwater noise, and entanglement. And these are measurable and understandable at the scale of single devices. And a lot can be learned from other marine industries for greater scale. In addition, these effects are likely to be additive with the size of arrays. And last, we have changes in habitats, and these are mainly similar to those of other marine industries. We may see some ecosystem-wide effects with arrays, and we understand that the footprint for the effects will increase with the size of arrays. Next slide, please. So last topic is cumulative effect. No, the next topic. my bad, I have another one. So now on to the cumulative effects focus area, which is led by Beth Fulton in Australia. And this topic looks at the direct and indirect effects from a variety of activities that occur within a region over time. So the study of cumulative effects come from the fields of medicine and toxicology and has since been applied to fisheries and other marine activities at sea. And a lot can be learned and transferred from this application to the marine energy industry, trying not to repeat the pitfalls of previous application. And the main questions are, what kind of cumulative effects are we talking about? How do they interact with each other? And what tools can we use to assess them? Next slide, please. So studying cumulative effects is a little more complicated than just adding effects onto each other. And we have different forms of cumulative effects. So they could be additive, and additive is the sum, even or not, of all these effects. Masking is when the effect from one stressor dominates the whole signal. Synergistic is when the interaction of multiple stressors is greater than the sum of their individual effects. And antagonistic is the opposite, when the interaction is lower than the sum. So most of these assessments so far assume that the effects are additive and often struggle with a non-linear form, especially because of the lack of data to properly investigate. And because of that, studies often use modeling approaches. However, the different industries have used many different approaches to assess cumulative effects, such as GIS tools, expert knowledge, numerical models, and mixed approaches. Next slide, please. So the last focus area is the ecosystem approach, which this topic is led by a team at France Énergie Marine in France. And the approach is defined by the Convention on Biological Diversity, which currently does not specifically mention marine energy. An ecosystem approach is an integrated management strategy that promotes the equitable conservation and sustainable use of resources and spaces, and follows scientific methodologies that include biological processes, function, and interactions among organisms and their environment. So with this focused area, the questions that we are looking at are related to how marine energy may affect the ecosystem and ecosystem services. Next slide, please. So the team has developed a series of conceptual frameworks that describe qualitatively the interaction between ecosystem components and marine energy system. So like the one here on the right for changes in benthic and pelagic habitats. It's a ball and stick model that depicts the relationship between components of a trophic network, abiotic processes, and marine energy devices. And the team who is in charge of this topic has also reviewed the literature available on the topic, especially regarding the various numerical modeling approaches available to assess their applicability to marine energy. We also created a survey that went out to experts in the field to refine the definition of ecosystem approach as it applies to marine energy, and to also identify knowledge gaps specific to ecosystem for marine renewable energy. So that's what we have for these three topics. Next slide, please. And now I'm going to talk about another topic that we tackled this year, which is a better understanding of what are the environmental effects of marine renewable energy in tropical and subtropical regions. So far, studies examining the environmental effects of marine renewable energy have primarily focused on deployments in temperate regions and countries in the Northern Hemisphere. And the highest untapped source of marine renewable energy are located in tropical and subtropical coastline. And there is often an overlap between these marine renewable energy resources and the biodiversity hotspot. So we do need to examine the potential environmental effects specific to these regions and their unique habitats and species. And this year, we've been collecting information on marine renewable energy and environmental effect through an online survey and also through expert interviews. And here we had our colleagues from Aquaterra who have helped us during these interviews. So if you're interested in this topic, and if you also have information on marine renewable energy project or studies on environmental effects in those tropical and subtropical regions, we still have the survey open. You can see the link at the bottom on the slide here, and we also have a QR code. And we are currently working to understand which additional environmental interaction are relevant for this tropical and subtropical regions. So we have all this interaction that we have presented at the beginning of the webinar, but can we have other interactions that could be applicable in these regions? So we are working on that. Next slide, please. So the next, this is a new one. So this is a new stressor receptor interaction that we've been looking at this year, which is displacement. We don't know a lot about displacement, and because the industry is starting to move from single devices to, we are at least starting to think about what would be the environmental effect from single devices to arrays. So as we talked about in the scaling up to arrays topic earlier, we want to better understand what is displacement. So we've worked this year on defining displacement and better understanding which methods could be used to better assess and understand displacement. So the definition of displacement that we have is here. It's an outcome of one of three mechanisms, which are attraction, avoidance, and exclusion, triggered by receptors' response to one or more stressors. And there is potential for a range of consequences, from effects on individual to populations. For example, we could have bioenergetic losses or an increase in predation. Animals that are the most susceptible with displacement are, for example, large whales, sea turtles, forage fish, or benthic sharks. And we are planning an expert forum, the early next year probably, to gather feedbacks from international experts on definition and methods. So if you have expertise on this topic, and if you are interested in being with us in this expert forum, please let us know in the chat here, or we will have our contacts at the end. Next slide, please. So now, collision risk. This is one of the key stressors interaction we have defined under OES-Environmental. And this year, we took a deeper dive on this topic. The risk of collision between marine animals and turbine blades continues to be the first question raised by regulators upon hearing of new tidal or river projects. And it is the most significant issue that slows permitting and in some cases has contributed to the abandonment of project. This issue has been difficult to resolve in part because observation of interaction of animal with turbines is very expensive, time-consuming, and often unfruitful. So to go towards a better understanding of the collision risk stressors, this year we developed an evidence base, which you can access with this link on the slide. The collision risk evidence base consists of key research studies and reports that define what we understand about the risk of collision with tidal turbines for marine animal, fish, and diving seabirds. This year, we also worked on a list of priorities and methods for understanding collision risk, and we developed a research framework to assess collision risk for fish. Finally, we developed some recommendations. So we have a few examples here, and these recommendations are to help better understanding collision risk and to go towards better assessment also of collision risk. So our recommendations are that first, there is a need to design research projects that will fulfill data needs for models. We should ensure that collision risk monitoring is required for each turbine deployment, designed to answer the important questions for collision risk for fish, marine mammal, and diving seabirds as appropriate. There is need to document and communicate the most appropriate set of instruments that will provide observation of collision risk. And as the industry progresses, we should ensure that solid models take the place of extensive data collection efforts at each new project site. So that's all I had. Next slide, please. And I'm going to let Debbie talk. Thank you.
Yeah, thanks, Lisel. So in addition to some of our content-specific and synthesis work that people have been describing, OES-Environmental has also been developing outreach materials for various audiences to share more information broadly about the environmental effects of marine energy. And each of these resources can be accessed using the QR code on the screen or the link that will be added to the chat. So for new regulators and advisors, we have developed the MRE brochure shown here, which provides an overview of each stressor receptor interaction, the current level of risk of that interaction, and case studies from real-world deployments that consider environmental effects. For K-12 and university students, we have curated an educational resources page on TETHIS to host age-appropriate presentations and downloadable coloring pages that we develop for each stressor receptor interaction. As we develop more student-facing content in the future, it will be added to this page. And then lastly, for all audiences, we have been developing a video series in partnership with the U.S. Department of Energy's Water Power Technologies Office and PNNL's communications team for an overview of environmental effects, one for underwater noise, one for EMF, and one for habitat change. And those will be released in early November of this year. We have also engaged with several podcasts to produce episodes that conclude discussion of environmental effects of marine energy. And as far as next steps for OES-Environmental, I think you've heard a bit about each of these throughout our talks today, but just wanted to summarize them here. We are working on finishing up the remaining guidance documents and planning additional outreach to regulators internationally. And as Michaela mentioned, we'll be hosting a workshop to gather feedback on the guidance documents and discuss pathways to application this fall. And so we'll be following up with folks that we think might be interested in participating, but if you really want to make sure you're included, feel free to reach out to us. We're also continuing to work on collision risk and displacement, planning a displacement expert forum coming soon. And we'll be continuing our efforts on the systems approach that Liesl described. And lastly, as Andrea mentioned, we are starting to think about producing the next State of the Science report for 2024. So stay tuned for that. It's 2 years out, but takes quite a bit of work to put that together. So with that, we would love to take any of your questions as a team here, and we'd like to request that you complete our 4-minute survey about this presentation at the link that I'll drop in the chat or at the QR code. So thank you very much.